In lesson 7-5, we're really going to get into somewhat what you might think of dividing polynomials, but we actually call it factoring polynomials. This keyword of factoring is such an important skill. You're going to start learning it now, and you will use it throughout all of Algebra 2. So zone in, get good at it, and practice a ton of them. Now, let's go back to section 7-3, where we learned to multiply these polynomials. So if we were going to multiply x plus 2 by x plus 3, I'm going to do a generic rectangle here, and we could practice what we learned. X times x makes x squared, 2 times x makes 2x, 3 times x is 3x, and don't forget to multiply. 2 times 3 makes 6. So my final answer is x squared, 2x and 3x makes 5x, and 2 times 3 made 6. There is the standard form after I multiplied my two binomials. Now, they have the same picture over here with the algebra tiles. If you've ever used those, we'd have this as an x squared. That's because it's x times x. Here I've got my two x's. Now they did their 2 on this side and their 3. I did it backwards, but it will result in the same answer. We want to be able to take something like this standard polynomial written in standard form and get it back into two things that multiply to give you that answer. So it's like reverse thinking. So let's try if I wanted to factor this. Now we kind of know the answer because we're aware that we have this factored form with two binomials to multiply, and we know what the answer is. But let's pretend we have no idea what we just did up there. If you were to find what multiplies to give you these terms here, our x squared is always at the top. We tend to have been in the pattern where our x squared goes here. That's our first term. Now notice it's a 1x squared. That's very important. And then my final term here is the 6. Okay, I'm going to have my 6 in this bottom box here. I have 2 boxes left, and I want to make 5 x's go in there. Now, you could put a 1 and a 4, or a 2 and a 3, maybe 0 and 5. It's kind of like thinking of them as toys. You want to have these 2 toy boxes filled with a total of 5 x's. We know these outsides are going to be x times x to make x squared. If we took a 2 and a 3, 2 times 3 would make 6. And 3 times x is 3x, and 2 times x is 2x. We could try to guess these two numbers that would multiply to this last box in the bottom right here, but also add to each other to make the 5x. So our factored form would be, as we kind of already know, x plus 3 from the top of our rectangle times x plus 2. Sometimes my students will kind of understand this box method, but they forget to write the final factored form. It's important that you take the outside of your boxes and write them in their two binomial form. Let's try another one. So here I have my x squared. That first one is always in that top left box. We usually put our highest power up here. Then our 36, notice it's a positive 36. That's important to pay attention to. It goes in this bottom one. I also want to highlight out to you here to help make your job a little bit easier in the future. Remember there's a 1 here with the 1x squared. I want you to think of this 1 times 36 to make 36. It will just help you down the road when we get to a little bit more trickier ones. So let's try to do a guessing game here. We want to fill out the outside of our boxes. We know that if we have x times x, we make x squared. That one I feel pretty confident about. We need to have something here and something here that multiply to 36. But I've got this box in the middle here. I have to place these 2 toy boxes, if you will. Need to put 13 x's in there total. So this requires you to think of what multiplies to 36. 1 times 36, 2 times 18, 3 times 12, 4 times 8. Wait, no, hold on. Just kidding, bad math. 4 times 9, that is. Okay, but wait, what if 4 times 9 makes 36? I wonder what 4 plus 9 is. Let's try it. 4 times x is 4x. X times 9 is 9x. Is 9x added to 14x, those two toy boxes, if you will, going to fill in 13x? It sure will. And 9 times 4 is 36. Just because you get your puzzle done and you fill out all the correct spots, again, don't forget that you need to write the factored form. Factored form means two of these binomials multiplied by each other. So let's try one more here. We want our x squared to go in our top box here. We have our 28, and since there's a 1 with the x squared, we have 1 times 28, still will be 28 here. And I want to fill in these two middle boxes to make a total of 11. But in order to do that, I know that I need two numbers. My x times x will make x squared. I need two numbers here in this spot, these two spots, to multiply to 28. So let's think of factors of 28. 1 times 28, 2 times 14. Oh, how about 7 times 4? Wait, 7 plus 4 is 11. If I put a 7 here and a 4 here, I'm going to get 4x and 7x, which together, those make my 11x's. That's what I wanted, and we know 7 times 4 is 28. So my final answer will be x plus 7 times x plus 4. Some might ask, does it matter which order you write your final answer in? It does not. Some might put the 7 on the left and the 4 on the top. As long as you have an x plus 4 and an x plus 7, you'll have the correct factored form. Just don't forget to write it. Here we go again. You cannot practice enough of these, promise. You will always have more that you can practice and get better and better at. I also know, be careful here, there's a negative 6. So if I want to get this negative 6, I have to write that sign in here. That's important to watch. And keep in mind, we have a 1 out here, so that's going to be why it's 1 times negative 6. I need these middle boxes, these two toy boxes as I refer to them, to add up to 5. Now, I will recommend always thinking of what multiplies. What are these two things going to be that multiply to negative 6? One of them has to be negative. Let's think of things that make 6. 1 times 6 and 2 times 3. Many students will think, oh look, 2 plus 3 is 5. Sure, that's true. But if you had a 2x and a 3x, neither of them would be negative, and you need one of those to be negative. So if we try our 6 and our 1, I'm going to put a 6 here and a 1 here. Which one would we want to have a negative sign in front of it? So it multiplies to negative 6, but it also will make 5 when we have 6x and 1x. I think I want to subtract 1 from 6. And now 6x, take away 1x, would be 5x. So don't forget, your final answer is in factored form, x plus 6 times x minus 1. Negatives can make it a little bit tricky, but it's always important you carry the sign before each term. Now, we can multiply x's and y's, but if we're multiplying, I still recommend that you use your generic rectangle. So I'll just try one of them here. I've got my x plus 2y and my x plus 4y. Nothing different here. We're going to use just a couple variables. So x times x is x squared. 2y times x is 2xy. I prefer to write them in alphabetical order. If you put 2yx, that would also be okay. 4y times x is 4xy. And now 2 times 4 is 8. Numbers still follow the same multiplication rule. But y times y makes y squared. So since I was doing this first example here, my final standard form would be my x squared. I've got 2xy and 4xy, so I'll put those together, would give me 6xy and 8y squared. You can check the book or your answer key packet if you multiply these out, but just use your generic rectangles again. Same rules apply whether it's an x or a y. You'll see this at the bottom of your packet page. As I mentioned, there is not ever too many factoring problems that you can do. So make sure you try all of these, check the answer key, and use your generic rectangle. They'll always be helpful. Please keep in mind as we get ready to head into the next section, every single one of these has 1x squared. We're going to step up our game in the next section where there's not a 1. But keep in mind, if you were setting up your box, your x squared's in the top left. Your -4 is down here, and that's also because a -4 times 1 is a -4. We'll use that in our next example to help us do more difficult factoring.